help. Okay, welcome to LIGO Workshop, day 3. We had an amazing 2 days. We learned a lot the last 2 days, and today we're going to be learning something more exciting. And let me give you a small brief about LIGO Workshop, whatever that we are doing for people who've not joined us for the last 2 days. It is the ideal workshop for smart contract developers at any level who want to improve their Web3 development skills. Implementing and developing projects is the greatest approach to learn any program language, and you will be learning LIGO from scratch with the core LIGOlang team and building hands-on projects like games, NFT marketplaces, dApps, and etc. Today, we will be talking about the extending the first dApp. We're going to be understanding inter-contract calls, view and test, and build your second dApp. And today's speaker is Bnejamin Fuentes. Thank you so much, Bnejamin, for joining us once again.
Hi, everyone.
And I hope all of you remember Bnejamin from yesterday, but those of you do not, and if it's your first thing, let me just give you a small brief about Bnejamin. Bnejamin has several years of experience in blockchain development and cloud. After passing some time with IBM, with Hyperledger Fabric, he is now a part of the Tezos ecosystem. So we're really grateful to have Bnejamin be a part of Tezos ecosystem. And thank you so much, Bnejamin. The stage is yours.
Okay, you're welcome. Thank you. So welcome for the second day for the poker game. I hope that people that were here yesterday, because this is an improvement of the first training. So we need to have the code of yesterday. In case you just join or you remove already the code yesterday, you can go back to the first Git repository for the training one, and you go to the folder solution, and then you can copy paste the code from yesterday from the solution, and we can start from here. Even that, I recommend you to, like yesterday, to install the prerequisite. They're the same like yesterday, so if you were here, you don't have to do it. But for newcomers today, install the prerequisites here at the link. And the link for today, the training 2, is here. Okay, so I will just recap what we have done yesterday. So if you remember yesterday, we were doing a poker game. So it's a dApp composed of a smart contract written in JS LIGO, that is a JavaScript-like language. And we deploy this contract into a testnet that is Ithaca, that is version N today. Then what we have done is to write the front-end part, that is a React application. We added a library named Taquido to interact with our blockchain. And we use an indexer too. Just remember the flow diagram yesterday was very easy. So you connect to your front-end application as a user, connect to your wallet. Once you're connected to your wallet, you have a button and you're able to poke any smart contract that is displayed on the web page. And the smart contract is tracing, so it's registering the address of the user that is connecting and poking to it. And then we display the people who are poking. So we display the storage of the smart contract on the front end. Just to have a look for the people who ran it here yesterday, it looks like a bit like this. So you have a button connect, disconnect, you display your address. This is the amount of tests, that balance you have. And then you fetch your contracts who are deployed on the testnet. So this is the first column, and on each contract, you have a poke button, and you display the storage of the people who poke you. So poke this contract. That's pretty much what we did yesterday. So easy sequence diagram. easy use case. What we are going to do today is to make this use case a little bit more complex to see other things. In fact, we will start with unit testing. How to unit test your JS LIGO code. So this is a smart contract. No, we're not going to test the React application, not the goal here. So just unit testing the smart contract. We will see how to do inter-contract calls. So a contract calling another contract. We will see how to use views, but the way of reading a storage of another contract. So it's an iteration contract to contract, but is read-only mode and is a very simple approach and less complex at the first solution. And at one moment we will launch and we write and we launch a mutation test to see what is mutation test and why LIGO is providing mutation test in the test library. And we will have a fun with that. Okay, so let's see what we want to have as a target at the end. So the new poke sequence diagram, we change a bit the scenario now. So we had a user poking one smart contract before. Now we want to use the first smart contract we are poking. And this smart contract, we poke another one. And this other one, we send back a feedback to our smart contract and we store the trace. So the difference here is we are not only storing the address of the user here who is poking, but also we are storing, we will store the address of this smart contract that is poked on the second time and the feedback that is hiding on his storage. So every smart contract here that will be poked at the end, we have kind of a secret feedback and we will store this feedback in the traces and we will display it later. Okay, let's people now, I think they are installing the prerequisites if they were not here yesterday. I will go a little bit faster for the people who are here. So what we do now, we take the code from yesterday. So here is the smart contract source code that we have yesterday. So take yours if you have it locally, or just copy paste the source of the smart contract of yesterday. Okay, what we are going to do, we are going to change a bit the way we are storing the traces. Okay, so first we will only unit test a simple scenario of poking. So not with a full complex flow, just we want to test a simple poke, okay? So if we poke, we just register the contract owner address and feedback with empty string, okay? Because we just do one poke here, but not poke and get feedback. And we will have, later we will write a second function, poke and get feedback, that will do all the full flow, okay? But we will just, for the moment, just unit test a poke, not getting the feedback. Okay, so change the storage you had yesterday. Let me see. Okay. So the storage would be poker traces, and this time will be a map of address and a poke message. So the address will remain to be normally the user that is poking the contract. So like yesterday, the set of addresses, we keep these addresses here. And we will add in our map new information as a value. It will be an object, poke message. And on this message, it will be a receiver address. So it means the address of the second contract and a feedback. In our case, it will be for the moment an empty string. So because we don't have yet, so we will modify the poke function. And as we don't have yet a second contract in this message, we just register as an address the contract itself here, okay, as a receiver. It will be the smart contract one because we don't have a two, so it will be this address, and the pgap empty string because we don't have a smart contract number 2. And the rest remain the same. So if you have the code of yesterday, you should have something similar to this part. And what we are changing here is we are changing the storage. So we have to now register this object structure. So it will be a map now. So just a few words about this code. Let me check. Hi, Benjamin, could you please speak a bit more energy and enthusiasm? I am French, that's why. Probably please the loudspeaker to take the workshop in their own pace. Okay. Yeah. So we are going to change the way we store. We have the storage with a map. So here we change the set. We had a set.add yesterday, and now we have a map.add. So we use a map now. So we use the function add of the map. The first parameter of a map is the key. So the key is like yesterday, Tezos.source means it's is the user as origin of the first transaction. So it remains the same. The value now we have this new object is a feedback message. So it's a structure. So you can create an object like this, like in JavaScript, the same. And you register. So Tezos.self-address means that it is actually the address of the contract that is executing this transaction. Okay. So in our case, it's a contract number 1. And a figure, we leave it empty for the moment because we don't have a contract 2. And the last parameter is map we're going to modify. Okay, so why this kind of structure here? We start with building an object and we do like this. It's called functional updates. It means that we want to modify the store object. So we are going to do a copy. This means a copy. So if you create an object and you start like this, means that I want to copy all the values and fields of this object. And the first comma is what you are going to modify. So I want to modify the field pocket trace, and this is a new value. And if I have to modify another fields, I will add a new comma and I will add the new fields. And I will give another value, etc., etc. So this is nothing specific to JS LIGO. This is JavaScript, where you can copy all the values of an object. So you have to use this way. Okay. What else? I think I talk about everything. So the map library that you are using, the functional updates, like a copy of an object and a modification of the fields. And okay, I added also this one. It will be used for later. This is a secret feedback that I was talking about when we have a second contract. So for the moment, we add this field, but we don't do anything with that, but we will use it later. Okay, I think we have everything here. So what you can do is to compile again your JS LIGO file, just to check if everything is fine. So if you are here, you can go to your smart contract folder, and then just compile it. So you see, I don't output yet the Microsoft code to deploy it. So it just render the Microsoft code. If you have that and with no warning errors, it means that the compilation is successful. Okay. So I let you a bit of time to replace the POC function, modify the storage types. So everything is types here. So it's our type definitions. So we have a new type, POC message, you modify the storage, and you modify the POC function. Okay, let me check if everyone is okay. Can I go forward? Okay. So if your code compiles, I hope to, or you copy mine in the solution. Now we go to the unit test. Okay, so the second diagram here is just a poke, and we just store, etc. So with what we did just before. So now we can create a new file for the unit test. There is no convention on the name of the unit file. So I saw people, they start with unit prefix. So you can do like me. Good. You can do like me or whatever. Just to remember, this is a JS LIGO file for unit testing. Okay, you have some links on the test module if you want to look at it. So copy paste after, and I will explain how to do this unit test. So copy paste the code that you have here for the unit test. And I will start the explanations. So I have in the same folder, but you can separate if you want, having a source folder and a test folder, like you separate. Oops. Okay, so I'll start the explanation. On the first line, normally you should have an import, and this is the source file that you want to test. So I import to the path of my source file. So I want to test pokergame.js LIGO, and I give it namespace. Let's call a namespace or whatever. It's just the alias, because the alias is important. If you import several files and they have the same definitions of variables or functions, etc., it will be a duplication. You will not know which. For example, it's very common to have a lot of source files with a main because it's mandatory. So if you import two files, they have a main function, then you have a duplicate definition, and the compiler will complain saying you have duplicate definition of main. So that's why you have this alias, and you will start like this, as you see here, for example. Poker game dot something means that you want to use a parameter variable of this alias that's coming from this file. Okay, it's a way of doing this. So first line you import. So you import your source file, you name it like you want, the poker game or the contract you want to contract, you can name it if you want. After, I'm not talking about that, I will talk about later because I have the version, the final version with mutation test. I will explain later. So you have this version with this line. So here is where you initiate your context of simulation of a testnet, if you want. So it's the state simulates here that you're initiating a blockchain, and on the test framework. It's not a real one. The first parameter is the number of accounts you want to create. So user accounts you want to create. And here you can leave it to an empty array. It's just if you want to initialize with a specific balance some of the accounts. So just leave it as default because it's largely enough to do some tests. So I create two, for example. So I will have two accounts. What I'm doing just next line, I'm taking the first account that has been created on the list here. So at index 0 means I'm taking the first one. And I will use as a faucet or my baker, means that it will be the one that will process the transaction for me. and requires a lot of money to process the transaction. So it would be a faucet or a baker, whatever. It will process my transaction. So I'll set it later. I will say that this user will be my baker to process my transactions. I will take the second account as a typical user. I will call it sender1. And I can do some logging on the test framework. So as you see, maybe in Microsoft, you're not able to see any logs. So you're not able to do logs on the source file. We didn't do anything yesterday about, never talk about logging in your source file contract. Is because you cannot log. You cannot log on the Microsoft. So, but you can log on a unit test. So we are going to have some display to be able to debug in case we have errors. Would be useful. So what I'm doing here is just I'm using test every time I use the test library. So test have a function get balance. It simulates like the CLI of Tezos client. It's the same. So it's doing get balance of an address and trying to display the balance of my user one, that is sender one. Okay, I need to set the baker, like I said, and the source would be on the CLI, the default wallet we are using. When you say transferring, Tezos client transfer XTZ from a user, this is a from. So by default, I will put the faucet, but later I will change it to the sender, the user that I want. I can change it later. This section is about utility functions, and we talk just after. Why? Because the test framework will run all the function starting with test. It's a bit like unit, JUnit, if you know. If you start with test, it will be taken as a unit test, and it will be displayed on the output, etc., etc. And we have a Boolean that he has passed on. So everything that starts with test here will be run. So that's the way to run the test. If you want already, just to show you, but you will take this. So LIGO run test. This is the way to run the test. This is a command, and you pass your unit test. I have my display of logs, as you see, and you see at the end, this is all the functions starting with test. So it has taken only this one. That is the only one starting with test. And what I'm doing here, I will call another function. So I can write here a block of things, like a function with a block with information. But if you do, if you do test, you know already that you have different scenarios, and what you just want to change is just the value every time to change the scenario. So you want to change the user that is doing the transaction, so it would be sender one, sender two, etc. And you want to just little things, or and you don't want to rewrite every time the same. So I factorize here in another function. So I prefix to say that this is not something I want to display at the end. This is my factorized function here for testing box. And I want to have this maybe later. I want to have more scenarios. So I will do a number 2 here. I will change here. I will put a sender 2, and I will have more users, etc., etc. That's the way. Okay, I will continue, and I will answer the question of too short. Okay, let's go now to see what is inside this function here. So I'm passing 2 arguments, but in your version, because you have this version, you are passing only 1 argument, that is a sender. Okay, let's see the sender. So I will hide because this is a mutation part. This is for later. Let's check this version is easier to understand than the one that you have. So what I'm doing here, I'm passing an address that would be the user that is doing the transaction. So just after what I'm doing here is test.setSource. I'll say, okay, the one that will do the transaction next will be a user and the user passing parameter. So in my case, it will be sender one. Next, I'm calling transfer to contract. So this is the same as the CLI. It's the transfer the transfer command. So it means I want to do a transaction. I'm passing as first parameter the contract. So you should have this part that is the initialization of the contract and the deployment of the contract. So let's have a look on it. So when you're starting the test, you will run these lines. And this line said that I want to originate, so I want to deploy something, and my something is the main. So I need to point to a main of a contract. So if you remember, you were doing an include here. So I have another version because it's next. The include is a bit like you have the version with include. So the include is a bit like the import. It's just like it doesn't have any namespace. So it's just taking the file and just adding the file if you want at the beginning. So you don't need to have domain names or namespace here. So when I say main, in fact, main is defined in this file. So you will find it in this file. Okay. This is the main function of this file, because here there is no main definition. So we will find it here. Okay, so I say that I want the main of this contract. It's a kind of a pointer to this contract, pointing to the entry point of the main function. It's what I need. And I need to have initialization of the storage. So this is the way I'm doing the initialization. So it's an empty map of this type, okay, and contains this stuff. So this is a big object, then has a map and a second piece that is a feedback. So in our case, we have to initialize feedback. So you can put whatever here, keys, whatever. We will see later when we deploy, we will change its value and we will more fun. This is for the feedback later. And how many you are going to pay, so you can put 0 as test. So it's deploying the contract here, taking the new address. So it's a kind of type address. It's not really an address, it's a type address. And from an type address, you can get the contract object and the way to do it. So this is a contract object. So this is parameter that I'm going to call here. I need a contract object. Okay. From a contract object, I'm able to use Tezos address and give me also the contract address. So this is address type. So will be used later, you see. And you can also display the contract object, and we should give you the contract address on the logs. Okay, so we said that we are going to do a transfer. So it's a transaction. So we point to the contract that we want to do the call. Second parameter is a parameter of the contract. So yes, like yesterday, it's the poke parameter. So we call poke like yesterday, and we don't pay any tests because we don't need. And you get back a status, and then you display the status. Oh, 2 seconds. Okay. Once you have the status, just for debugging the status in case you have a problem, then it will give you what's the error returned by the contract operation. In this case, an operation. Well, you can get the storage. So it will be the storage after calling this function. There should be a change. You can log it for debugging purpose. So it's inside of the storage. And then you can do some assertions. So I had a question about Mocha Che. Yes, this is something that you can see like Mocha or Che, or also a JUnit if you were if you are a Java developer too. 3 unit testing, so you can do scenarios the same. You don't have it starting with it with a display, but at the end, what it displayed you see here is the name that you have here. So you can name it like I want to test sender one that is poking, etc. You can have some logs, so you can display the logs and tracing your unit test. And you have the same of assertion mechanism, like all the, so you have assert with error. So this is the part I'm talking now. So it's okay, it's nice to have the logs, etc. But when you're unit testing, what you want to use is assertions. You want the test to pass or the test to fail. That's the goal. So you have this assert or assert with error. I'm using assert with error because like this, I have also a display of a message. It's more talkative. So what I want to do. So first of all, I want to see if S, so remember S is the parameter here, so is the user address, so it's sender1. I want to find sender1 as a key. So map.find optional here means I want to find from a key a value. It's like get if you want, map.get the same, but it return an optional. I will explain what is an optional just after. So I want from the key, so I want from search from sender1 in this case in my map. So store.poctraces is a map of user and the value is a poc message. So I want to find this user. If I don't find it, then I have an error, so I return false. Why? Because when I say poc, I have to register a trace. That's what I did, and the trace is the key is the user and the value is the poc message. So first I need to find this user. If I don't find it, I return false. Okay, and here I should have false value. I mean my test failed. If I found one, so why I need to do this? Because I have an optional here. So let's talk about an optional. I'm doing a switch case here about an optional. This function is never sure to find the user. Because if in my math the key does not exist, not returning to me null or undefined, not the way in JS LIGO, it will return me an optional object, if you class if you want. And an optional is some or none. Okay, some means that it has an element, so you can see optional in different languages. Java has optionals or other ones. So some contains an object, so it means that has been found. And none means that this object has not been found, it's empty. Okay. So what I need to do is a switch case. So you remember yesterday the match is a switch case. So I can do a match on an optional. It means that I want to test if the optional has this value. So in the case of some, I can do something. In the case of none, I want to do something. Remember yesterday, JS LIGO is deterministic. So everything we want to have here, we don't let the people to be in a branch that we don't know what to do and let's pass. This is everything functional. So every case has to need to have an output and to do something. So we said about the case none, that means that we don't find the sender, so we return an error. It's false for the test. And if we found the user, we will get the value. So here we get the value. So we get the value, and we said that with this value, we will, so it's a function definition, with this value that we will get from the sum. Now we will do something. Okay, think functional. So we get the poc message. I'm sure we have a value here. So it's a poc message of type poc message. And then what we do here, this is definition of the function. So we have the body. I don't know if I can not enlarge too much. I will do an assertion. I want to test the fields of my poc message to see if it's exactly what I said. So remember I said that my feedback by default, it was an empty string. Is what we did on the code. If you remember, if I take the code, we said that for poc, we have a feedback that should be empty. So we test that this feedback is still empty. Okay. And if we fail because the asset with error, the second argument is a string and you put whatever you want. So in my second, I said feedback and I display what I found is not equal to what I was expecting, empty. So I say I was expecting empty and I found this guy. Okay, And then I continue. So I can continue again, and I can have a second assertion, and I want to test the receiver feed this time. So the first parameter is a condition that you understand. This is a test you are going to do in that session. So it returns a Boolean. I want my receiver to be my contract address, because what I said here, the receiver should be the contract address itself, self.address. So I'm checking that. And contract address is something that I fetch before, remember, from the contract I was extracting the contract address. And the same second argument is a string, and this is the error if in case it's not equal. So I say receiver is not equal to the contract address. If I pass at the end, I return true, because I have passed what I said before. Okay, I think I explained all the parts here. Yes. Yes. I put the link to the reference test. So to run the test is LIGO run test and the name of your unit test. And you should have a series of logs that you have done before. So in the logs, remember we display a string here, and then we display the balance. Another string that we display the contract. So the contract object here is returning, as you see, the address of the contract. Here is what I'm doing the status. If you remember the status somewhere, I'm displaying the status. I'm displaying the status of my operation here. So this is status. So I have success. In case you have a problem here, you have rejected, and you have an error message with a fade with. Then I'm displaying the storage. So this is the storage. This is the state of my contract after calling the operation. So you see a lot of things inside. It's good if you want to manually test and you are not sure what you are asserting just after. So I'm displaying the storage, and then I'm doing my assertions, and see that there is no logs of errors anywhere. And at the end, I have value true, mean that assertion passed, and I got true at the end. Okay, let me, if you did you get the success on the unit? One day I had a question why we are not doing directly Mocha or JavaScript unit testing here. Why we have to use still.js LIGO? Well, as you see, there is a lot of test libraries here. So how you want to simulate that? In fact, you need this test library, and this test library, I think, is written in OCaml. We don't have the library in JavaScript to import this test library yet, at least. So that's why we are written this test in JS LIGO, and we are using the test library. And this test library is maintained by the LIGO team. So they provide you everything that you need to interact with a fake blockchain. So you don't have to simulate the blockchain like this, because it's quite complex to do that. So you still use the JS LIGO. Like this also, you can import files. They are in the same language. It's very important, because how you import the file, you can test the functions if you are not in the same language. It's a bit complicated. So here you import JS LIGO, you are in JS LIGO, so you are able to use main function because it's the same language, etc. At the enter. At the end is very similar to the unit test framework that you know in other languages. Okay, so is your test compiling and running correctly? Can I go forward? Okay, fine. Okay, that's the most complete part. part after. So this part is a bit complex now. So take a breath. So now what we are doing is a complex flow. So we leave it with a unit test. We come back later with a mutation test. But now we are going to come back to the source code and to modify the sequence. So I would say don't touch the POC function for the moment. We are going to write a new function that is poke and get feedback. Like this, we have different ways of doing that. So we keep the poke because it works, and we will have poke and get feedback, and this is a new sequence diagram for poke and get feedback. So you remember the first sequence diagram you saw on the introduction is this one. So we are going to have the same, so a user that is poking a smart contract. And this time we call another function that is poke and get feedback. Okay, so we write this new function. And this new function here will call a second contract and ask for a feedback. So we write another function, get feedback on this contract. And then it will return the feedback through a callback. We call a callback. And it's another function. So it's the same name as this one, and I add callback at the end, just to remember this is a callback of this function. And then I store this feedback in the trace. Okay. So everything is asynchronous here. So I cannot do this execution from here to here in a synchronous way. So that's why I have two functions. One is the first part, I will call it the first part of the function poke get feedback, and I will call it this the second part, that is the callback function. Like this, with two functions, I'm able to do asynchronous. So calling this one is terminates this operation here on this contract starts, send the feedback, terminates, and then I have another part here that starts and terminates. Okay, now what we have in 3 execution instead of having one synchronous with etc. So because we are not in the same machine, we are in different machines, everything is asynchronous, that's why we have this. Okay, well, normally what I should do, I should write this get feedback function is in another file for a second contract, but I'm a bit lazy and I will reuse the same code that will contains all the functions. Like this, I can deploy 2 times my code in 2 instances of the contract, and I can play like this, just calling this one from the first contract and this function from the second contract. But I will use the same source code; it will be easier for us for the moment. But in real world, we should write 2 different contracts. Okay. Okay. So let's see the parameters of each function. So the first function here we take other, that it is an address. So other would be the address of the other contract I'm going to call. So here, smart contract P. And this one, the function that is here, callback, will receive the feedback object from the second contract. And this object I write as a return feedback. We see what is inside. And then, oh, there are 2 people joining still. My get feedback function requires a parameter or variable. I will name it contract callback because it is of type, I will call it Oracle parameter. Let's see just after what is inside. Just a few words about why I call it, for example, here the type Oracle, where it comes from. This is not the company Oracle, is Oracle. So in blockchain world, there are some contracts, we call them oracles. There are specific contracts, in fact, and the goal of an oracle is to provide information to other contracts. So yesterday I said that you are not able to call an API from a contract that is inside of a blockchain. You cannot call an API that is on the cloud, for example. It's not possible because everything is sandboxed. So how you do that? How you can get information from the outside? Well, it's called the Oracle solution. So you have a specific contract that receive information from the outside. So the push is from off-chain. So you have a push from off-chain that is going to this Oracle contract. And this guy is receiving information and it's storing this information. As this information is on his storage on-chain this time, well, other applications that are on-chain too are able to either call operation on it, like here, get feedback. So I want to see what you have in your storage about this feedback data that I'm searching for. Or we will see later, we can use views to see inside of the storage without passing through operations transaction. So that's why I'm calling this SMP here, smart contract P. I'm calling it an Oracle because for me, I will use it as just read-only way to get this feedback data here. Okay, so I just want to search on the storage feedback data. So I will call it an Oracle because effectively I'm just in read-only mode with this contract. Okay, so let's start with some changes. So get back to your code of pokergame.js LIGO, and you're going to modify things. So first, I was talking about this return feedback type definition here is of type address and string. So his is a pair definition, so we call that a pair. So the address is the address that gives the feedback, and a string message that the feedback's inside. Okay, that is returned by the Oracle, so the smart contract number 2. This object that you see here is a type of pair, is the address of this guy and the feedback message. Then we're talking about the Oracle param. So the Oracle param is the argument that is received by the getFeedback function. So the Oracle param is of type contract and typed of return feedback. This is the type of return of my contract. That's why I need to type it, okay? Because it will be a lot of check and verification that the types correspond. So it's a type of contract. So receiving here, this function here is receiving as parameter a type contract. Why? It's because this contract, when this function is called, it needs to know where to do the callback. So in fact, what I will point to here as a parameter is say, okay, this guy will say, well, I calling you here, and my parameter here will be a pointer to my callback function. Okay, like this, you will be able, when you receive my parameter, to answer me on this specific endpoint here. Okay, I hope it's clear. Okay, well, so you have 2 new types, and you have to change your parameter of the main function. So you had before only 1 line. So the variant here, the enum that you have, you only 1 function, it was to poke only. And now we have much more. So you have poke get feedback, that's the new one, that is cut in 2 parts. So this is a part 1, this is a part 2. And you have also this one, because we say that we're a bit cheating and we are putting all the function in the same source file. And then we will deploy 2 times the same. So the main here, so you go to the main, so you have the parameters, so you should have 4. This is my final version, so you will see later why we did not do this anymore. So you should have now 4 functions that are exposed, so 4 entry points for your contract now. So because you have 4, remember you need and you are obliged to declare for each of the variant of your main what you have to do. So poke, you leave it like this, still have poke and it's alone. Poke get feedback. This time we said that we are passing the address of the second contract to call. So you are taking this address, and what you do, you are creating a new function, poke get feedback, where you pass this address and you are going to modify. You need to pass the store because you need to return the store at the end. You have the callback. So we said this type, we receive this kind of object, and we do the same. We call new function with the same name. We pass the feedback and the store again. And get feedback, we said that we need this kind of Oracle params, and we call get feedback. So every time I use, it's a good practice to use the name of your entry point and calling a function that has the same name. But you can change it, it's not a constraint here. So I'm passing this object here and the store again. Okay, so now what I need to do is to write all of this function now, because it's what is missing. Okay, explanation. It was explained about the types and return types. So let's start with first, that is easiest function is the get feedback. Remember the get feedback is this one. So is the one that is receiving get feedback with an address with a callback, and then it's returning an object is a pair with the address of this guy plus the feedback string. So let's see this function first. So write a new function on your file, get feedback. So we said that to receive a callback, contract callback of this type, and a store of type storage. Oops, sorry. What we have here, okay, is here, this function here. So we are defining this function here. Okay, let's see what we are doing here. Okay, return type is always the same. It's mandatory. It's the same as the main. So what we want to do now, like you see on the sequence diagram, you don't want to modify the storage of this contract. You are not going to modify anything. You're just going to read what is the feedback on the storage, but not going to modify it, okay? But what you are going to do, and it's the first time you will see that now, is to do a call. So you want to do an operation. So the output of this function is at the end an operation. So you want to do an operation that is a transaction, and you want to call this endpoint, okay, and pass some parameters on it. So let's see how we can do that. Okay, so we define an operation type, and we use the library Tezos.transaction. So here we say we want to do a transaction, and the arguments of this transaction is first one, parameters, second one, the amount of Tez you want to pay. So in our case, always 0. And here where you want to call. So here is the endpoint you want to call. So in Tezos, an endpoint or a contract is the same in the way for him is a pointer to an entry point. So the entry point by default contract is the main function, or is an entry point that is inside, so after the main function. So here, I don't want to point to the main function. I don't want to call the main function of my first contract. I don't want to call the main function here. I want to call this entry point because it will be the second part of the flow that I want to run. So this is the guy I want. And how can I get him? Well, it has been passing parameters by the first contract, so it's easy. I'm just taking it and just passing it here. The second contract has nothing to be smart or whatever. You say, okay, it's telling me to answer here. Okay, answer here. And this is what I have in the parameter. So it will be one passing in the return. So here the feedback that is returned. So I'm passing it as parameter. It will be received and used by the other function. And we said that we want an address and a string. So address is myself, the contract number 2, the oracle, and the string is what I have in the storage as a feedback field. And that's it. And when I'm returning, the store is still the store, not modifying anything. And now I have an operation in the list of operation to execute. So that's why I'm passing the operation, OP. Okay, for this first function here. Any question about this function on the Oracle? Something that is weird, you don't really understand here. I remember here it has to pass, you have to pass one argument. The way to pass several items on a row is to put them on an array. So an array here is a pair because there are 2 elements. But you can have multiples, a tuple. Okay, we go forward. So nope, no query, good. Okay, so we have finished the get feedback function. Now we are going to write this one, and then at the end, this one. Okay, poke and get feedback. Let's see. Poke and get feedback. So on the main, we said we are receiving an address. So it will be the Oracle address or the address of the second contract. It was called other before, remember the variable. So we will receive this address of the second contract and the storage. Okay, let's look at the sequence diagram. Let's see what we have to do. So we are here, we receive a parameter with another contract to call, okay? And what we have to do is just calling this point here. And just that, because we are not going to modify anything here, I guess. Okay, just we need to call this guy and ask him for feedback. Let's see if it's that. Okay, so we come back here. Okay, first thing we want to do is to fetch this entry point. So the way to do that is, okay, so the entry point is get feedback. So we know the name of the function we are going to call. And we are going to use this function, Tezos.get entry point, optional again. So Tezos.get entry points need to take as first parameter the string of the function. It has to start with this percentage. I'm sorry, this is convention, and has to be lowercase. So you will find this a lot of time in Michelson. So there are a lot of things like this. You have to start with a percentage and a lowercase, means that you are pointing to an entry point. It's like this. Means that I want to call this entry point somewhere, and I need as a second parameters to give the where is the address of the contract where it's leaving this entry point. So it's pretty much done here. So it's returning an optional again, because if I call this contract and this function does not exist, well, what I do is the same again. I need to do something. I cannot leave it like this. What in the code, well, is it undefined what I do? Let pass the stuff here. No, everything has to be checked and verified, and everything need to have an action. It's deterministic. So my optional here, I need to test it. So that way I have again a switch case here on the optional that is returned by this function. That's why I have none and some. Let's see what is the return type here. It says that it's an optional of contract, and it's returning an Oracle param. Okay. This is the signature of this entry point. This is correct. So what I do, let's see. If I don't find this entry point on this contract, then I fail. Here, none. I don't find it, I fail. And I can add a string here. So no Oracle found. Even more is no endpoint get feedback on this Oracle file, if I want to be more precise. If I find one is what I want, a contract will be returned to me. And type contract, like I said, is the same as entry point, the same. So here, in fact, get feedback will to me a type contract. And we saw here is a contract type. It's not a function or entry point object, it's a contract type. So I get this contract, and what I'm doing, just returning this contract, and I put it on a variable. Okay. So this variable, I know that is filled with something, otherwise it has failed before. So I have this variable, and it's a function. So when I will do the transaction just after, so I'm doing the transaction because I said that the output should be a list of operations. The operation is calling the second contract. So I need to do the transaction, and I would pass. So this function needs to be executed. So I need to pass this function to be executed here as to be resolved if you want. So it has to be resolved at this point, and it will be the entry point I want to call. So you will pass the transaction to the entry point, get feedback. That's what I want. Good. Second parameter 0, we don't care. And what I have to pass here as a parameter. So if you remember, a parameter has to be this type because we are passing a contract object that is the callback for the Oracle to be able to call back later. So it's a type contract. And how do I define this? I can use that instead of doing Tezos.get entry point something. Well, I know this is my function is on my own contract, so I can do Tezos.self. It means that I'm searching for a function in my contract and with this name. Okay, this is my entry point. So I say my callback here is transformed as a contract doing this. So this function is returned as a contract doing this, and I'm passing you as a parameter. So then you will be able to call my callback later. Okay. So if I come back here to the sequence diagram here in the parameter, I'm passing a pointer to my function here, to this guy. Okay, what is it? Here, okay? I'm calling this guy, that is the Oracle, and I'm passing a pointer to my callback function. And that's pretty much what I have to do. Okay, for the first part of poke and get feedback. So we have done part 1, the get feedback of the Oracle, and it's missing the callback function. Okay, so let's go to the callback function. What we are doing here, for first, let's see the sequence diagram. So we are called, we know what we are called by another contract, and it will pass us as a parameter a feedback object. Okay, and we need to store the feedback. Okay, so we know we are going to modify the storage, and we are going to receive a feedback from somewhere, and we don't have to call anymore. Okay, let's see. Let's see. No, here. Okay, so we receive a return feedback object. Okay, I name it feedback. I have the store that is passing parameter from the main function already. And what I do, so I'm taking this object. I know it's a pair because we saw before it's a pair of address and string. So I'm building my object here because I know that has to be a type of feedback message. So I know that my first field is receiver. So I'm taking the feedback 0, that is the address. And my second field is feedback. And I'm taking the second part of the pair, that is a string with the feedback inside. So here I have forged my object of the good type, and I'm ready to modify my map. So here, remember, is the same code as you have in the poke. In the poke function, the first poke function. So what I do is just I don't do any operation, and I just modify my storage, adding a new element in my pocket trace, and that's it. The easiest one, I think. Yeah, I remember again, but yeah, this is a way to modify an object functional updates. So you copy the fields and you modify one field for several of this object. Now what we have to add is a new feedback. So remember here is a user. So the key is a user at the origin of the first call. It's not the direct caller. If I use Tezos.sender here, it will give me who is actually calling me, means that this is the oracle I should get. But I want the source of the user at the origin of the first call. And the feedback message is the one that you receive from the oracle. I do forge here, and then you have the map that you want to modify. Okay, so now you can compile again. Well, in my case, I have another version, so it should be okay. So you should have the maker zone and no errors. Okay, be fine. If you want later, you can try to do unit testing for that, but it's a bit more complex. Okay, are you okay with this sequence diagram before I start talking about the views? So are you fine? I would say the more complex part is to really have the correct type definitions everywhere, because everything is linked here, so you have to pass the correct types every time. So the compiler will complain if you're not aligned with the functions and types and returns types. The compiler will tell you that something is wrong. Okay, so you understand that you have really chunk parts everywhere of execution here, here, here. So every time you have a call, you have to pay fees. So what some people ask me, how much it costs to do these things? It costs most money than, yeah, it costs most money because when your node is estimating, so it's deterministic everything. So you're looking at all the function you're calling here. Internal core in a contract. I will terminate and I will ask you what you mean by internal core. Where every time you have an operation, you pay fees for an operation here, that's a transaction, etc. So node is estimating how many transactions you have in the whole execution, and how is deterministic. There is no way to say, okay, I don't know how many. No, you know how many times you have to call, etc. and it terminates. So it's more every time you do another call to another contract, the estimation grow, okay, in gas, because it takes more time. So more CPU time, it means more gas, means more money. Is this sequence what's known internal call in a contract? Is not internal call, is inter contract call. So it means that call between contracts. It's not intra, it's inter. Intra means inside contract itself, so it's alone. Inter, it means that we have different contracts in the same blockchain. They're discussing all together. I think sometimes you could see something called internal calls with the Tezos blockchain. I think these are consensus call inside of Tezos. It's nothing to do with your smart contract. It's more about Tezos itself that is could do some synchronization, do internal calls. I think some blockchains their heavy computation. They say, wow, we have a lot of transaction. And when you look at it and you see that this kind of blockchain, in fact, there are a lot of internal calls. They call that internal calls. They are kind of calls between elements, components of the blockchain itself, but there is no activity at all, I would say, about people deploying smart contracts. It's something that is inside the blockchain itself. So don't get confused on some blockchains. Say we have a lot of TPS, the transaction per second, and when you look after and you see that it's more internal calls of the blockchain itself there, but there is no really user activity on it. You know, internal transfer. Yeah. What you are here is internal transfer. I mean that there is not something that is relative to. So there are protocol or core transfer. It's not something relative to the activity of smart contract deployed by people. And what is really important, of course, is important because more inter-transfer you have in the blockchain, less you have space for the other to do a real business. You know, so you should have the less internal transfer possible. You know, to let the people deploy their own smart contracts. This is what is interesting in the business is people deploying contracts, not the blockchain itself trying to synchronize. The business doesn't care about that. They don't want to hear that. They don't want to spend money for internal contract code. No more. So yeah. In Better Call Dev, I think you have this rate of internal transfer. You can see what is a part of the blockchain itself and what is a part of the business, real business. We finished the most complex part. So now we talk about views. If you're okay, do you have more question on these contracts, or the other contracts? That is very common. It's an ecosystem, so you're able to call any contract that has endpoint. In a blockchain, there is no specific barriers. You can have, for example, barriers to call a contract if the contract has you to pay some money. Okay. If you know that an endpoint asks you one test, for example, to get some information and you don't pay, it's a kind of barrier. Okay, you have to pay to get information, but you are still able to call it. It would be refused, and they will say you have to pay one test point, but you still can call it. So you're able to call any contract from any contract. Technically speaking. Okay, about views now. That's the best part. So you saw it could be costly. And you have a link here. I encourage you to see this link. Very nice link about explaining how you estimate the cost of a full sequence. And it's telling you, for example, that inter-contract codes are quite expensive because chaining, you have a lot of operation increase the CPU time of execution, that is the gas fees at the end, and you will pay. So the caller of the first transaction will pay for everything, you know, everything. So it can increase a lot if you have a lot of chains and callbacks everywhere. So there is another way to do the things. It's called views. They work a little bit the same, but at the end it's less costly. Why? Views, they are perfect for oracles. Why? Because views, they are a way to look at the storage of a smart contract without passing an operation. And this is a big change. Because you will not have to pay so much doing this. Looking inside of a storage where you are in a node, all the contracts are executing on the node. So you are able to access the storage that is on your own machine, in fact. So you don't need to pass transaction in the network to synchronize something. You just want to do a read operation. So you're not going to modify anything. Yeah. Think about blockchain is everything about write and read. Okay. Reading is not costly. Writing is costly because it implies a consensus. Okay. Reading doesn't imply any consensus. So here we have the view, and the view doesn't imply consensus, you read the storage. It's like when you read on a DB and you're in a distributed database and you're in an optimistic way and you say, okay, this is what I see at this moment. Maybe it's not true because there is this distribution of database everywhere, and maybe it will be updated. But at this time, this is what I read, and it's maybe a dirty read, but I get this information, so it's free and it's fast. So you can see the view like this. So we have an Oracle here. We do read only, so we don't really need to do an operation. So instead of that, we will use a view, and we will read directly the feedback on the storage of the smart contract. So we'll save a lot of calls and money and time. So let's see how to do that. You see, I change a bit our dot line here, because we are not passing transaction this time. We are just reading the storage. What did change on the code? Well, a lot of things. We don't have get feedback function here anymore. We don't have a callback function here anymore. So we can remove or comment like I did here. We can comment the two functions that you have, the callback and the feedback, out. This is a lot of simplification. Yeah, just first. Then you can also comment on the main, because you don't have this function here, so you don't have to expose it. And you can go also on the parameters, because this function and entry point doesn't exist anymore. So at the end, you have just poke, that the initial one that we keep, and the poke and get feedback is only one function this time. So it's in a synchronous way. That's a big difference. Okay, so a lot of simplification. After, well, we have to use a view. So how would you use a view? It's quite simple. So now, instead of calling the other contract, the Oracle, now you use a view, and you use Tezos.coView. That's the function. You give view name. That's an alias if you want, view name. You can pass some parameter. In our case, we don't need any parameter. We just want to get the view. And the address of the Oracle, okay, is a contract address we want to point to. And what is returned is an optional of string, because I know my feedback will be a string. So I want just a string, okay? And I guess that's feedback optional. And because it's an optional, I need to stay saying, so I have some or none. If I have none, it's a problem, because I know that I should have a feedback view on the other contract, so I fail with. It's an exception for error here. If I get the feedback, is what I want. Normally, you should get the feedback. Well, I'm doing like before, encode that before. I'm returning my my storage updated. That's the same code as before. So you see the code now, it's very short. Okay, it's magic, but where is it view? Well, I remember the view. So before I had the function get feedback, now I have to declare a view. I can go there and I can declare a view. So the way to declare a view somewhere in a contract is we need an annotation at view. So I put it in a comment, otherwise it will think that the compiler will think that is something it needs to execute, but it's not something that the compiler needs to execute. So that's why I have to put that on a comment, and it will be a metadata, okay, for the compiler. So we look at it as the metadata. If we look on the comment, you will see that there is something with an annotation on the comments. For him, it's a metadata information. So I put in a comment at view parameter here to say that this is here what I'm declaring here as the variable will be exposed as a view. Okay. And this is my alias of the variable that I want to expose the view. I name it feedback, because here I said that it was named feedback. Okay. And what is this? Is a function that should return something. So is my function. So here I have no choice about the parameter. It has to be first a parameter of what you want. So in my case, I don't want anything here passed as a parameter. Like I said, I don't need any information to be passed when I'm calling the view. So I say unit void you want, the type is field, I don't care. And here I said that, like in Go, I have an underscore saying that this variable, I don't do anything with it because I don't care. The second is the storage. So I'm accessing the storage, so it will be injected if you want the storage. And I'm returning a string, okay? And the body of my function is I want to restore, to return store.feedback, okay? Just the feedback I have in the store, and it is a string, that's it, point. And it's done. So you see that the code is shorter and is also cheaper at the end because of the flow. And it synchronizes time to be faster. Yeah. Well, what else? I think, yeah, you can compile again. So you can compile again this code. So it's the code I compile because I have the last version. It's the last version of the code. So you have finished with all the sequence play game. So you compile and you have this flow ready. Let's check if everyone is okay. Okay, for explanation, and is it compiling well? So you have to be careful to comment what is not necessary. So it's on the list here. Just check. I just said what you have to do. Everything here you have to comment. So comment on the main, comment functions, comment entry points that you don't need anymore. And here you can even comment here because you don't use, but well, it will not complain if you don't use the types. So it will complain if you don't use a function, if you don't use a variable, or if you don't use a type, it's not complaining, compiler. And should be fine. Yeah. Okay, so I think we are in the last part of the smart contract section. Okay, the mutation test. I will talk about the mutation test now. So views is just as testing a storage, yes. Read only, yeah. You can even pass parameter if you want to indicate something to the other contract, but you always return read-only stuff. Yeah. You cannot modify the store. More question about views? I encourage you to use views if your use case is to just read. Loops and filter in the view, yes, I think yes. It's a code function. You can try to filter and fetch information that you need. Yeah. Don't modify the object on the storage. Just search for something and return it. Yeah. You can expose even the full storage, but it could be big sometimes. So just return what is necessary for the other contracts to access. That's it. Maybe they don't need to access to everything. Mutation test. Okay, so I think most of you knows about unit test. But what is mutation test? So LIGO provides you mutation test, so you don't have to import a framework for that. LIGO is doing that for you. That's a good point. Mutation tests are very easy to integrate. That's another very good point. So you don't have to modify the code so much. You don't have to write, in fact, a lot of tests because it will test your test, in fact. How can I explain mutation test? So consider that you have written, so for having mutation test, you need two things. You need the code of your contract, and you need the unit test for this code. So there are two things that are mandatory first. And you can consider the mutation test as a test testing the quality of your unit test. Okay. How it does that? You can consider that a bit like a coverage, but it's much better than coverage. The mutation test will run your unit test, but several times. And every time you will run your unit test, it will change something on the source file. Okay, about the something. What is something? Let's have a look on other frameworks because we don't have yet this table of explaining what we are doing. Okay, some things are the list of things, like here. So it means that if somewhere in the code the mutation framework is finding a plus b, you will replace it by a minus b. So it sounds a bit crazy because it will break in a way your code in a way, and it will pass the unit test all the time in a code that is broken. So it means that the mutation test want to test if your unit tests are still valid or not valid. And if you have written very well unit test, and if you break the code, it means that every time you change something on the mutation of your source file, the unit test should return that it fails instead of it passed. So it's the contrary. Okay, because unit test what you want to see if pass, 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 pass. Even if it's the contrary, then you say the test to fail. Sometimes you do test to fail. You want the test to fail to pass, and not to be rejected. It's test to fail. You're testing that is a failure, but you want it to pass at the end. So the Boolean should be true all the time. Okay. But when you do mutation tests, you do all the contrary. So when you want to see that your unit tests always return false because you change and you broke your code. So it should return false. And there is a lot of series of different things that it can do. You see here, it's crazy thing that it can do. So if it finds in any point a unit test that is passing and your code is broken, it's telling you that your unit code is shit, clearly, because it's something you were not expecting to test. You miss this test. Okay. Unit test should not say yes if your code is broken. It should say false because you have well tested it. So it's a way of doing coverage, but very good coverage. For me, it's much better to do mutation tests as coverage. Coverage is a bit cheating. Mutation test give you any choice. They will find any error everywhere. So it's very interesting. It's very new, I would say, in the way of testing. It has been discovered a lot of time ago, but it required before a lot of power, because you can imagine the number of combination to do mutation on your code is bigger is your code, longer is the execution of all this combination, running all the time unit test, unit test, unit test. It could take quite a lot. And before the machines, they were not performant. So it was something that never was used before. But now we have very good machines, and they're able in I would say normal time. You will see it will be very fast because we have very short source code. But I would say that in a normal time, it's acceptable to have this mutation test running and giving these very good results at the end. So let's try to do some mutation tests on our code using the test from of JS LIGO. So we don't have, like I said, to import new libraries, but we need to create a new file for testing mutation. So we create a new, so I recommend you to start with mutation underscore, okay? So you have the unit test, you need to have the source file, and you need to have a mutation file, okay? And then you copy paste this code, and I will explain you what it does. Okay, let you create the file and copy the content. We are good, 30 minutes. Yeah. Okay. Okay, you should have copies of file and the content. So like I said before, you need two things. You need the contract and you need the test. So I will name this poker game and I will name this file poker game test as a namespace. Okay. So I need to do some changes. Starting with this. Starting with this. You will see that the shape, it looks like a unit test a bit. It's because we are going to run the same command line. So you need to have at the end, I call it test mutation. So it's starting with test. So you'll be taken, like I said before, by the testing framework. And I will run it. So I have the command here. So you see, I will run LIGO run test. The same for the unit test, just to need to give the name of my mutation file. So I do the same. So I do a test mutation, and the test mutation is this function. It's a bit complex to explain. So how we start? Let me start with here. Okay. So I need to fetch. So I need to function to fetch my unit test. So it's because I will run the unit test on a source that is going to be modified. Okay. So here, what I'm doing here, I'm said that my test will be a test from my unit test file. So here, remember I had a function named testpoke. Oh, I don't think it works. I do like this, but this was the testpoke function of my unit file. So this is what I want to try. And this time I want to try this function, but remember I need to pass the sender one this time, but I want to change the main. So I want to change the source file every time because this guy will be changed by the test framework and mutated all the time. So before I did not need to pass this parameter here, but this time I want to change what is the code of my main function all the time. And this I need to pass it as a parameter and it will be of type main function. So this is a type main function I need to declare. So let's see how I declare that. So here, poker game test main function. So it's something that is defined here on this file and is of this type. And I declare it here. So it's a type of main. It's an entry point that I need to define. So it's this way I define this main. So the main is taking a parameter and is taking a storage. It's the main function. So it's taking a parameter, it's taking a storage. The type of the parameter is the parameter of the source file. And the type of the storage is the storage of the source file. And is returning a type that is a type of return from the source file. So it's just because I need to have definitions, okay? Because everything is type. Remember, everything is type in JSLIGO, so I need to declare all the types. So this is the way I declare what is the main function of my source file. And I'm using the keyword export because now I'm using import. And if I use import, I need to use export to the outside. So this is something that needs to be used by another file. So I need to export it from my file. Okay, so I come back to the mutation. So now it's okay. I know what is main. I know what is the type of main is declared. And I will run my unit test passing a main that will be mutated by the test framework and my parameters that I have as always for my unit test. Okay, so that's how can I define the test that will be run. Now I say I'm doing test mutation. So test mutation returns a Boolean because every unit test return Boolean if it passes, if it fails, so it's true or false. And it's returning, so this I will hide you a bit. It's a way to do some logs. So I'm calling this new function test.mutation test all. So by mutation test all means that all the combination of all this kind of, you remember this table here. So I want to pass all the mutations, I mean test all. We test all the mutations. I need to pass a parameter that is a pointer to my main. So this is pointing to the main of my source code. And test to run on it. Okay, this is my test here function that I have here. That it will run my unit test here. Okay, so what it does, the mutation test framework here, we do mutation on the first argument. So we look at the source code, so really on the code of this main, and it will change a lot of things in all the source file. Okay, and every time it will change something, it will call my unit test. It will change something, it will call my unit test for all the mutations that he has on register on the framework. Okay, and what it does is saying is returning a list of results. Okay, and I want to display, I want to log, if you want, what is on this list. So how I can do that? Well, I do a switch case and I look what is returned. Because if all the mutations are okay, it means that I should have an empty list. So I want to test. If I have an empty list at the end of my mutation test, it means that everything is fine. That everything has passed as expected. So it means that all the mutants, so these horrible mutants that have destroyed my code, they have been killed, if you want, by the unit test. So my unit tests are good and they kill the mutants. So I display no mutation errors and I return true. Perfect. Mutation is okay. But what happens if I have something in my list? It means that some mutants have been discovered. It means some of my unit tests say it's okay, but the mutants are here in my code. So it's a problem. So what I'm taking here, I'm taking the list. It's a list of Boolean and mutations. And so here is a way to decompose a list in JS LIGO. So you take the head and the rest of the list. And I look at the list and I want to do some logs. In fact, I want to log what has been discovered. So I will not kill you here. I'm just looking on the size. And every time I have a head, I have an element, I'm logging the mutation that has been found. And if I found something, I return false. The goal is to fail return false if I found a mutant. So I'm logging what I have found and I'm returning false. And here is just, if you want to look, it's just a recursive way of scrolling the list and logging every element. There's a way to do it in functional programming. Okay, if you want to have a look, it's just I'm logging and returning false. And that's pretty much. So I would say this file is okay now. It's explained. But there is something I have changed. If you remember, here I had an extra parameter that I didn't have before. So I need to change my unit test. And I need to change this function to take now a main that is of type main function. So I need to do that. And what it changed also is I need to deploy a new version of my contract every time. So this code before was because I was deploying only once and testing this contract. Okay, I was deploying the contract, testing this contract on my test, finish. This time my mutation test will run several times. So it will deploy a new version of my contract testing, new version of my contract testing, new version of my contract testing. So now I need to deploy in my function here directly. So I will deploy now in my function and not before once. So I will deploy X time, in fact, because it will be called X time. And here I have the main. Okay. So it will not be called by the unit test anymore. It will be called by the mutation test. So the mutation test will inject me the main, and I will use this main that has been injected to deploy the mutant contract. Okay. And that's pretty much what you have to do. Let me see if I have covered everything. So you have the mutation file, you copy paste. I've explained it. You have to use exports because all the time, so you look on your source file, you have to use exports because now you need to access from another file, you need to access this function, so all the types. So you need to export all the types and need to be used because I use now import, and the import requires that if you use something from the file, it has to be exported if you want to use it here. So you export the types, all the types that you have here. You export the main, and on the unit test where you have this definition now that I showed before, you have the import, you have this definition, you have this part that's been moved that it was before now it's inside. You have the main now that is a part of the arguments. And that's pretty much that. Okay, like here you can also point to the, and your unit work still works. Unit test still works. Okay, and if you do all the changes, so on the source files, on the unit test, and this new file of the mutation test, now you are able to run the mutation test. So run it. And in my case, it's perfect. But you should not have in your case. Why? Because I have already corrected the error. And now I will do like you. Oh yeah, no mutation. Say like this. And I have an error like you now. Okay, so what happened? So remember, the mutants will always try to invade you. So unit tests were correct before, so we don't understand what's going on. So it should pass, it should be okay. So what happened? It's telling you that a mutation has been found. So what happened? It says that on line 34 here, it has changed its value feedback by feedback, and your tests were okay. Okay. Why? Is because if you remember, we just test the poke function. If I look at here, we just test the poke function. And as we were doing poke get feedback, in fact, we forgot to change our unit test to test poke and get feedback. So he has run the test, he has changed the mutants, and he's saying that he's still passing, is right. We have not done a good coverage because we never tested this function. So the mutation here is right. They're invaders. It's because we have done a bad job here. We forgot to test one function. It's true. Poke and get feedback, it was a new function we added after the unit test and we never tested. So you see how the coverage is good. So you have two ways of fixing that. Or you could be lazy like me and you say, okay, I have no time to fix that right now. And I will add an annotation to tell my mutation framework to avoid to look at this. It will not change anything, include mutants or whatever. I told him to don't look at this, okay? And now it doesn't look like this, okay? And mutants disappear. It's because I don't have time to do this test. But what you should do is when you find something like this, you say, okay, that's something I haven't tested here. So what I will do is I will go to my unit test, and now this time I will test it. I will add a unit test for that. And if you test it well and you run again, the mutants will not find anymore that you missed to test this function. Okay, it is well understood about the mutation tests, how good they are, and they can really um, give you the quality of your unit test, in fact, and do some coverage. Yep. Any question about the mutants? Okay, I will pass to the second section if you want, before we finish. So now we have all the smart contracts that has the new version, but it's still tested locally. We have to deploy the new version, and though we have also to update our React application from yesterday, because we change a lot of things. And what we want to do now is not just to poke it, get feedback, because now we have new features. So we want to display this feature and play with these new features. Okay, so we are going to modify the React app to display these new features now and to play with that. So take the React application you had yesterday, or follow this link. If you were not here yesterday, you have the React app on the solution part that's called the app for the React app. And you will have to redeploy the new version of your smart contract. Okay. So let's go. Let's compile again, like yesterday. New version now. Okay, so I have to be on this folder. You could go up. No, smart. Yeah. And I will compile again. Okay, I have my Michelson ready. I will compile the storage. So look a bit on the storage because I have changed a bit. So listen to me now, but you can change this value here. Okay, the keys, don't put a keys, put whatever you want here. Like it would be funny because when I will try to poke you, you will give me another value that I don't know. So just change this value here and don't put me a keys, please. Otherwise, everyone with keys, everyone. Well, why not? Let's see, I will change that value and I will say, what else today? I don't know what to say today. I took a break. It's already done. I will say jump. I jump on you. Oh, why not? If you poke me, I jump on you. Okay. And let's redeploy your contract. So here you replace by your account of yesterday. I don't know what was the name of your account. I would use mine. I think it's Alice. Or have others from Bob or whatever. I will use Alice. Let's check if I'm okay. I'm rejecting my contract. So I'm erasing my alias of yesterday. I'm using the force to erase my contract name. I'm trying to 0 from Alice. I have my Michelson. I have initialization of my state. Should be fine. And I am on Ithaca network. So I just wait. Wake up, Ithaca. And I should have my new address of contract and I save it somewhere. I don't know. I'm saving somewhere. Where is my? Okay, I'm saving my contract address here because I will need it after to from my client side to point to the correct one. So don't forget to take your new address of contract and let's go to the React application. Okay, it's finished from this part. I don't need this anymore. I will remove it because I don't need it anymore. It has been deployed. And I will switch to the React application. Good. Okay, my React application always go to the same here, app.t6. What I need to do. Okay, so I will first need to update here the address of my deploy contract. So remember you were fetching similar contracts. So now you change completely the code. Huh? So the entry points are all different. So what you need to do is to point to the new version. And you cannot keep the old version, otherwise you will be on the training one. So take the new version. That's my new version. We need an object definition for displaying POC message. So copy paste is a receiver and a feedback. So you see here is not an address because we are in Taquito. Taquito is TypeScript, so it's a string, not an address type like in JS LIGO, but it's doing the conversion for you. So you just have to declare that it's a string. So I declare a POC message type, done. The contract to POC, I need a new parameter to enter. You remember, I want to POC contract from another contract. So I need to pass the address of another contract to POC. So in React, I'm declaring a new variable. So I think I have it here. Yes. So I'm declaring another contract to POC. It's an address, type string in TypeScript. And I'm going to change my POC function because this time I'm not going to have default here or POC. I want to have POC and get feedback and pass my new contract as parameter. Okay, so I need to change that line. So here, just copy paste the new POC function here. So I have POC and get feedback. And see, be careful, lowercase, always here, lowercase, and it's the name of your entry point. And pass the parameter that it's expecting, it's an address. So I'm passing the address of the contract I want to POC. And here I change a bit. I have an alert now. So when the transaction is done, you have an alert saying that you can refresh the page. Don't click all the time. And that's okay for this part. And now you need to change also the storage here. So when you display on the table what is inside, you will display differently because your storage has changed. Okay, so what you will do a table like before, but on the column in the middle, you will display the full content of your storage. So what I say content, the trace now is, we will display it like that, is the contract that gives the feedback. So it will be the address of this contract. The hidden feedback, so the verb if you want. So it, in my case, will be jump if you poke me. And the user that he has clicked on the button. So this contract has done something on this user. So it's what I will display now, and I leave the rest the same. Okay, just this still poke. Okay, I leave it poke, but it's poke and get feedback. Okay, and I think it's pretty much that. Yeah, I mean, I have to go to the React application. So I'm going to the React application and I'm going to run it. Do you have this? Yeah, okay. Yeah, run start. Let's go. Let's go. Let's go. Nope. Okay. So it's the same as yesterday. I'm cheating because I was logged. So I'm logging again. Where is putting my temple? No, I don't know. Reset connection. Temple is sleeping. It's locked, maybe. That's fine. No, no, he's awake. Come on. Wake up. Oh, today's not working well. No answer from your wallet. What happens to the wallet? I don't know why I cannot connect to my wallet. Oh, is something with Temple? A problem with Temple, maybe? If I connect with another wallet. Why you ask me always Temple if I okay. Which port is open? I will kill that. I will try to T and the problem with Temple. I don't know why. Come on. Let's see. Oh yes, I want to use Temple, so I don't use Temple. No answer. Or it has opened me somewhere. Sometimes it's opening me somewhere a pop-up, but I don't see where it is on my screen. I have different screens. Where is he? No, it's not hiding somewhere. No. No, I don't find it either. No answer from your wallet yet. Yeah, it's like it's opening somewhere a pop-up, and I don't see where is this pop-up. Where is this pop-up? No. No. I have three screens, so searching. No, it looks like he has a problem for today. I will try to disconnect that, so I will try to use another wallet, maybe. Let's do not touch. What can I use? I need to have some Tezos on it. Monitaka network. Which one can I use? If temple is set today, that's a bit weird. First time I have this temple that is down. Maybe if I look in the logs, if it's telling me something is beacon. What's going on? Is my fetch contract? Yes, it's normal, but yes. What is going on with this temple today? Because if I connect with another one, we don't have enough test to. Kuka is working, is connecting me. Yeah, but I don't have any test, so I will. I think it's temper that has a problem. Let me disconnect. Okay, try to reconnect with temple. Cannot find where is the pop-up of temple popping. No. Maybe they have done an update on the extension and they broke something because I don't see the pop-up somewhere. No, it's like the pop-up of temple is not showing up. And it's not telling me anything here. No, that's weird. Okay, can I do that if I connect to another? No, maybe it's the same. If I use, for example, it should be the same. If I use temple, it will tell me that there's a problem, right? Here you say I'm connected. You're not. It's a pop-up. It's crazy. No, it's a pop-up. If I do that, no, it's like there is no pop-up anymore to connect to Temple. Maybe they've done an update and they broke the extension because I can connect with Kukai, so it's like I can't connect to Itaka anymore with Temple. Yeah, it's the same everywhere. Okay, do we have? No, because air gap in Itaka doesn't work. I try to search for a solution because we are in the testnet and Temple is able to connect to normally to Itaka, but the other wallets normally they cannot connect because if I use Umami, it will tells me that there's no Itaka. Yeah, there's another network of the program with the others. They don't work with the other networks. So yeah, I'm connecting with Umami, but it's on the mainnet, so it doesn't want Itaka. Air gap. Let's try, but it will tell me the same. Does not support Itaka network, I'm sure. Yeah, network not supported. Perfect. Nice. Which option I have? Normally it's working with Temple. That's I try this one, but I don't have. I will send maybe money to this guy and it's finished. Yeah, I will do that. I will do that. Let's try that. Because Kuka is working on Itaka. Yeah. I need to take the address of this guy and there's always a way to, I will send money to this guy. Yes, because in Kukai, you don't have your own, you don't really own your own address. They generate this one for you. You cannot import, but there is an option to import, but not very great. Doesn't work very well. We send Tezos and I will send it as Sprocket. Yeah, boom. And you receive my money. Okay. Let's refresh. Arrives here. I'm in Taka network. Let's see. It says that it's still pending. Okay, that's why. Oh, maybe it's the network that is, maybe it's not Temple, the problem. Maybe it's a testnet that is very slow. That is maybe the real problem because my transaction is pending. That's not normal. Okay, what is going on here? No, there are some blocks. Oh yeah, it's slow. Okay, so I'm connected with my Kukai. Hey, it's me, Kukai. Fresh. I have money now. Good. Okay, sorry for that. I don't know why Temple has a problem with the extension today because it's doing upgrades of versions under the hood. So in your browser, you're not controlling the upgrade. So if they deploy the version and they break something, and then your extension is broken, but you see that with Kukai, apparently it works still. Some connected with another user, with the user I use for Kukai for testing, send some tests, you see, it works, and now I can fetch contracts. So this is the version. So I think that this is mine or this is mine, I don't remember. One of these one is mine. Salute. Ah, yeah, there are some people playing. Okay, so what I want to do now is I want to remember if we the second diagram. Okay, we have the one with the view, but it's the same. I want to pass an address of a smart contract on the POC and get feedback. So I will test, okay, this guy. So I will use this one as my first contract, and I will use the other one as the Oracle. It's POC. Okay, asking me validation. Okay. Okay. Accept it. So I did an alert normally. Oh, already done. Fast. I can refresh. Good. So it means that I use this one as a first contract. So he has store a trace, and he has called this guy, and this guy apparently has a feedback. So is this guy? See? So he's giving me a feedback salute to me, and I am this address. So perfect. It means that I think I remember it's me who deployed this contract. So I will do the contrary now. I will take my contract as an oracle, and I will use this one or whoever I want to here displayed here. And I will use myself as the second contract as the oracle. So it should give me this contract, give me a jump on me. Okay, confirm again. Let's see. Okay, let's refresh. Okay, so my contract that I deploy, so it's a jump, my feedback, yeah, on me. Yeah. Okay. So if you have a problem like me with the last version of Temple, that I will look, where is this version of Temple that has been deployed? Changed something here. I think it was 13, no, before. So maybe they have a bug here. So if you have the last version of Tempo like me and you have a problem with connecting now, because I don't see the pop-up anymore. I was working yesterday, but not today. Then you can use Kukai like me, and you send money to your Kukai from your account you have, and then you can connect. Okay. Okay, let me check on the chat. Where is the chat here? If I have question. Tempo on another website working. Tempo on another website. What can I use? This. I'm already connected. Let's see. I don't have the pop-up. There is a problem with the version of Tempo that I have. I don't know what happened. They have been updated, but I cannot connect anymore because I don't see the. No, I don't have the pop-up anymore. It's open. Yeah, my wallet is open. It's like he's not seeing my wallet open or whatever. I don't know. I see it's a plenty. It's not a problem with the website or the code of Takido or Beacon SDK. I think it's a problem with my version of Tempo. Maybe I need to reinstall Tempo. I don't know. But yeah, I cannot connect to any website today. That's really bad. Really bad. Because yeah, the network works. I can send transaction. Now it looks like it's problem with my extension now today. Okay, I will try to debug. Okay, it's good to have different wallets types to be able to still connect. Tell me where you are, if you have already finished or you are still changing some code. Maybe on the web page on Tempo, I can have a look. Website repo. Let's see what they have done recently. Because they are doing a lot of updates recently because they have the mobile app version now. Okay, they have a link on before. People. Let's see if they have something that is released. No, 10 days ago. The one I have. Yeah, but I updated my Chrome this morning. I updated my Chrome this morning. Maybe I had the previous version before I updated Chrome. It's quite recent. What they have done, I don't know. We have changed some stuff, but not too much. Supported primitive view in protocol Edo. Or which version of LIGO are you using? Because Edo protocol is quite old. And if Edo protocol is the default of the compiler, it means that maybe you have a old version of LIGO. That's weird. Yeah, because views maybe in Edo were not existing. Yeah, pretty sure. So yeah, can you update your LIGO version to more than 0.40? I think we are 0.42 or 43 now. 43 now. Yeah. Yeah, go to the last version of LIGO, it will be better. Yeah, because the compiler will take one of the protocol to compile and to make a code. And if your LIGO version is old, it will try to compile in Edo or Angzu. And if it's recent, he will try to compile in Ithaca version of Mickelson. So we have views and all the last features. Okay, I'm a bit worried with my tempo, so I will need to debug that this morning. I will install and reinstall temporary thing in case, because I don't have any pop-up anymore. But here it's everything perfect. That is what is weird. It's everything connected and perfect. But if I use with any website, it's like there is a problem. Which other one? I have one here. I sign out. I try to connect my wallet. Let me try again. And there is no pop-up. All the websites. It's all the websites. That means that this is my browser extension. And the last version is failing. Well, it's something I haven't done is to add the issues sometimes. No, I don't think something opened recently. It's a temporary extension, so maybe I will add an issue. Let's see, maybe they don't know. Because if they work on different and they test only the mainnet, maybe they don't know if Ithaca has a problem. So I will give them the and see what is about that. We create an issue to see if it's mine. I need to reinstall or not. All right. And now it can't. It's not showing up. Selecting the sample wallet. Let's see. Okay. Okay, I'm taking question for the last 10 minutes and then I will conclude with today's session. What's your question or if you need some help on some parts or to explain? Question about how you create upgradable logic main contract. Of course, or another. Yes, in fact, yes. It's the mechanism to do that. Well, in my next training that's not finished yet, I will have a section talking about how to upgrade the contract. So you will see different ways of upgrading contract, and one of the way is to have what is called a proxy contract. So the role of the proxy contract is to redirect you to the correct version of the new contract that has been deployed. So yes, it is a way it's doing kind of a pass-through, proxyifying. So you call always the same proxy contract, and then this contract just forward your request to the version of the contract that is the latest one. So yeah, that's one of the trick for upgrading. Have you fixed the problem with the LIGO version and the view? Yep. Okay. Good. And which temporal version do you have? Do you use Chrome? Because I'm pretty sure there's something to do with Chrome update this morning, because the only thing I did from yesterday night it was working. So I have the same version on Firefox. I will try on Firefox. So okay, I will try on Firefox. I have the same problem. I can be just Google Chrome maybe with the last update. Could be because there was an update this morning. I don't know if I put that. Yeah, I put that on the. Okay. More question, or I conclude for today. If you're okay. No, I hope everything was clear. Yeah. Cool. No problems. Perfect. So I will just recap what we have done today. What we have done today, we have done unit testing, mutation test. I hope it was new for you that you discover a new way of testing. We saw how to call contracts, calling another contract. We noticed that, it could be complex and cost money and be a quite long execution. So if you don't need to have this way and just need to read, you can use views, and views are much better for that. Next time, I have to finish next training, but I will talk about how to operate smart contract and to use Lambda to change the code of your smart contract also, and tickets. So tickets are very important. You will see what are tickets, what they are used for. Okay, I hope to do that before the during this summer, maybe I will be done. Okay, thank you everyone. Give back the end to Tezos India if you want to close.
Yeah. Thank you so much, Benjamin. Thank you so much to all of you who joined. Hope today's session was as good as the previous sessions as well. Great to see your participation. I'd like to say thank you to Benjamin once again. Tomorrow we will be joined by Didier, who took the first day workshop. So thank you so much, Benjamin, for doing this, taking your time out. I'm sure a lot of us learned a lot of things about LIGO, and do share your details in the chat box if people want to get in touch with you, so that they could follow you on your socials or anything, so that it'll be easier for them. And I would like all of you to also follow Tezos India on social media, so that whenever something like this is coming up, you will definitely be informed about it. Himanshu, could you please also give the Tezos India Twitter links? Benjamin also has shared his social link, so you can get in touch with him. And thank you so much once again to all of you who joined. I hope you all had a very good session. Tomorrow will be day 4 of the LIGO workshop, so do make sure that you join. and do follow us on Twitter, share it with your friends, and thank you so much. Good day. Thank you, Benjamin.
Thank you, everyone. Have a good day too. Bye bye.